When Ford announced the pricing for its new electric pickup, the Fathom, in August 2026, the specific baseline metric engineered to command the market's attention was $28,350.
That was the base MSRP for a vehicle equipped with its standard range battery.
Yes, and when you calculate the finalized destination charge, the starting figure arriving at the dealership came to $29,945. It sits deliberately, mathematically, just below the $30,000 threshold.
Which, for an electric pickup, introduces a fundamental tension that goes far beyond consumer marketing.
Exactly. Our mission is to examine a stack of institutional financial data and manufacturing blueprints to determine if Ford has actually solved the electric vehicle affordability crisis or if they are simply choosing to permanently subsidize a massive loss.
Right.
Because Ford planned the Fathom as the flagship vehicle on its universal electric vehicle platform, placing physical production at the Louisville assembly plant with initial customer deliveries scaling in 2027.
Which is the critical distinction you have to make when evaluating this kind of capital allocation. A low sticker price certainly proves affordability for the retail buyer. It does not, on its own, prove long-term profitability for Ford.
No, it does not.
The company entered this product cycle with extensive, painful evidence that unit volume and profit margin can aggressively diverge. Consider the balance sheet data from just before that pricing announcement. In the second quarter of 2026, Ford's Model E division reported an EBIT loss of $919 million.
That loss was generated on roughly $1 billion of revenue. Think about the gravity of those numbers for a moment.
For that full year, the guidance expected Model E to lose roughly $4 billion, and that is a figure that includes about $1 billion of incremental investment directed specifically at this universal EV platform and their energy business.
The stark institutional reality is that you cannot simply subsidize a $30,000 truck when operating at those negative run rates.
No, you can't.
I would argue that those massive quarterly losses are exactly why the traditional automotive margin model is completely obsolete here. For decades, the legacy framework for Detroit was relatively straightforward.
Protect the margins with premium add-ons.
Right. In the old days, automakers used luxury trims and massive engines like a thick winter coat to hide the extra weight of their manufacturing inefficiencies. If your factory floor was wasteful or your supply chain was bloated, you just hid that systemic cost under the high margins of a premium leather interior or a larger V8 engine.
That cushion absorbed the systemic inefficiencies.
But with an affordable EV at a $28,000 price point, you're effectively in a swimsuit. The cushion is completely gone. Every single unnecessary part, every redundant bolt, every wasted movement on the assembly line becomes glaringly visible on the balance sheet.
Well, look at the margin data first. You have to evaluate the specific manufacturing math they're using to attempt that structural fix.
Which requires fixing the engineering at the root blueprint level. The Fathom is not simply Ford trying to make an existing EV cheaper through aggressive feature deletion.
No, it is a mandatory attempt to physically alter the underlying economics before the truck ever reaches the showroom. It begins with the cost map of the architecture itself.
And that cost map dictates whether the program survives its first 24 months of production. Let's look at the quantified data on that clean sheet engineering. According to Ford's own metrics, the new universal EV platform utilizes roughly 20% fewer parts than a typical legacy vehicle.
It requires 25% fewer physical fasteners.
Right. It operates with roughly 40% fewer assembly workstations on the factory floor.
Consequently, the entire ecosystem is designed around a 15% reduction in total assembly time. Now, on the surface, those appear to be purely industrial manufacturing metrics.
But they represent the actual financial ledger of the vehicle.
Yes, because deleting a physical component removes significantly more than just the unit price printed on a Tier 1 supplier invoice. When you evaluate the life cycle of a single automotive part, you are looking at a compounding chain of capital expenditure.
Let us look at what deleting a single physical bracket actually means for the balance sheet. First, a salaried engineer has to design that specific bracket.
Another team has to validate it for crash safety and long-term durability.
The purchasing department has to negotiate a contract for it.
The logistics network pays diesel fuel to transport it.
The facility pays for square footage to warehouse it.
The assembly line pays an hourly worker to physically install it.
The quality control division pays someone to inspect it.
And finally, the balance sheet must carry a cash liability to support that bracket when the vehicle returns to the dealer under warranty.
Removing 20% of the total parts eliminates that entire massive chain of capital expenditure for every single deleted item. You cannot reliably turn an expensive EV architecture into an affordable one by simply removing a few digital convenience screens or seat heaters at the end of the development cycle.
By that point, the expensive structural architecture and the labor required to build it is already permanently locked in.
That structural architecture also dictates how the vehicle physically moves through the facility. Traditional automotive assembly is a rigid sequential process. The vehicle progresses down a very long linear conveyor belt, gradually gaining components as it moves from station to station over the course of hours.
Ford replaced that historical layout with a modular architecture they refer to as an assembly tree.
Yes, instead of one continuous line, Reuters documented 3 parallel production streams operating simultaneously at the Louisville plant. The front section, the rear section, and a central structural battery and interior section are built completely independently of one another.
They are joined much later in the process.
And they are also utilizing large aluminum unicastings. To put that in perspective, a unicasting is essentially a giant, single-piece metal mold. It is like replacing a complex 50-piece Lego structure with one solid, immovable brick.
Which completely eliminates dozens of individual stamped steel components that historically required heavy robotic welding.
Exactly. This reduces joining operations, minimizes material handling, and physically removes raw labor hours per vehicle.
That assumes the theoretical manufacturing process holds up under volume production, though. Parallel work streams mathematically reduce bottlenecks on a factory diagram, but you have to look at the operational reality.
The physical execution on the floor.
Right. Historically, if one operation on a sequential line stops, perhaps a robotic welder faults or a tool breaks, the entire 2-mile-long facility waits. Separate work streams theoretically isolate those delays, but factory diagrams do not equal operational margin.
Factories produce margin.
Yes, and the precision engineering required to achieve $28,000 economics demands full-price quality. That is precisely where operational reality introduces friction. Yield matters. Quality matters. Rework costs matter.
Downtime matters.
The parallel production strategy only functions efficiently if those massive aluminum unicastings and modular sections come together with zero tolerance issues. If the front casting does not perfectly align with the center structural battery pack, and a human worker has to intervene to manually rework the joining stage,
All of those projected labor savings evaporate immediately.
the moment a human has to force a fit, the vehicle loses money.
But even if the factory yield performs perfectly, even if the unicastings align with zero tolerance issues, a radically simplified body structure cannot fix the overall vehicle economics if the propulsion system remains disproportionately expensive.
The battery.
The battery. It is the vehicle's most expensive system and the most critical variable in the entire material equation. The standard range version of the Fathom utilizes lithium iron phosphate, or LFP, batteries.
By shifting to LFP chemistry, Ford completely avoids using nickel and cobalt in the cathode.
Which are some of the most price-volatile and geopolitically sensitive commodities on the planet. These LFP cells are produced domestically at Ford's Blue Oval Battery Park in Michigan. Ford entirely owns the U.S. plant, but they are producing prismatic LFP cells using manufacturing technology licensed directly from CATL.
That specific licensing agreement is a direct, calculated response to global geopolitical benchmarks. If you review the International Energy Agency's 2025 data, LFP represented more than 55% of total EV battery deployment globally.
But the critical data point from the IEA, the one that dictates Ford's entire strategy, is the pricing disparity.
In 2025, average battery pack prices in China were 30% lower than in North America.
That 30% deficit is the actual survival benchmark Ford must meet to make the Fathom viable.
The global market does not simply require 30% cheaper cars. It requires 30% cheaper battery packs on average. The cost of the battery permanently dictates the pricing floor of the entire vehicle platform. If you cannot produce the cells cheaply, you cannot sell the truck cheaply.
Which introduces a very rigid physical constraint regarding vehicle capacity. Ford initially withheld the final battery capacity and official driving range figures when they announced that base pricing in August.
They confirmed the standard range battery and clearly indicated that any additional range would cost the consumer significantly more.
Right. That creates a very rigid physical and financial trade-off that the industry often struggles to manage. Adding battery capacity to increase a vehicle's range means adding hundreds of individual cells. That adds massive physical weight.
And that weight then cascades through the rest of the vehicle's engineering. Suddenly, you require a stronger steel crash structure to protect the heavier battery.
You require heavier brake calipers to stop the extra mass.
You need entirely different, more expensive suspension tuning to manage the ride quality, all of which adds immense cost to the final product.
So the engineering challenge for you to consider is not how much battery can Ford possibly fit into the Fathom. The actual question driving the margin is how little battery can Ford use without making the vehicle entirely undesirable to the consumer.
That depends entirely on the infrastructure existing outside of the vehicle. The acceptable lower limit of battery capacity is dictated by the consumer's daily charging reality.
A buyer who plugs in at home every night, operating on a predictable 40-mile daily commute, may be perfectly comfortable with a smaller standard range pack.
But a consumer relying on public fast-charging infrastructure will value a much larger battery simply to reduce the frequency of agonizing public charging sessions. It is the exact same physical truck coming off the Louisville line, but the external ownership requirements dictate two entirely different utility profiles.
This connects the underlying battery cost directly to municipal charging convenience. If public charging access improves, manufacturers like Ford will not need to solve consumer range anxiety by installing thousands of dollars of expensive kilowatt hours into the floor of every single vehicle.
But Ford cannot control local municipal zoning laws. They cannot control apartment building electrical upgrades.
They cannot control public fast charging reliability. Therefore, a massive portion of the affordability problem, and by extension the margin problem, exists entirely outside of the vehicle's engineering.
Which brings us to the immense capital expenditure required to attempt this integration, and the automotive industry's dangerous tendency to rely on the utilization trap. Let us carefully examine the fixed capital stack.
Ford committed close to $2 billion to physically transform the Louisville assembly plant for this new EV system.
And when you combine that with the roughly $3 billion associated with the Michigan battery operation, Ford deployed about $5 billion of upfront investment behind this affordable EV manufacturing strategy.
That capital carries heavy costs, whether the assembly lines are running at 60 units an hour or sitting completely idle. The financial clock is always ticking. The factory equipment depreciates.
The physical facilities require constant maintenance.
The salaried engineers and plant management remain on payroll. The core engineering spending has already occurred, and that cash is gone.
And this is where the industry often leans on scaling out of a problem.
I have to challenge the traditional industry crutch here. The standard assumption among legacy automakers is that a manufacturer can simply scale their way out of a negative margin problem. Volume is frequently treated as a universal remedy for bad unit economics. It is a deeply ingrained belief that if you just build more units, the math will eventually fix itself.
It is a fundamentally flawed premise. Volume only helps if the unit economics of the individual vehicle are intrinsically healthy. If you are analyzing a business and you see that a manufacturer loses money on the variable costs that rise with every additional truck built, producing a higher volume of trucks simply scales the financial losses.
Think of it practically. If you lose $2 on every cup of lemonade you sell, building a significantly larger lemonade stand does not make you profitable. It just bankrupts you faster.
Scale amplifies the underlying math. It does not correct it.
Let us systematically calculate that contribution margin math, because it is the only metric that matters for recovering that $5 billion. To find the actual contribution margin, you start with the revenue Ford receives from the dealer for a single Fathom. Then you meticulously subtract the direct costs associated with producing that specific unit.
You subtract the raw cost of the battery cells. You subtract the power electronics, the electric motors,
The raw materials like aluminum and steel,
the external supplier content,
the direct manufacturing labor required at Louisville,
the statistical warranty expectations for future repairs.
and the outbound logistics of putting it on a rail car. Whatever capital remains after that final subtraction is the contribution margin.
That remainder is the only cash that contributes toward recovering the $5 billion of fixed investment. Only after that contribution margin is strictly positive does higher plant utilization actually improve the economics by spreading the fixed costs across more units.
Which confirms exactly why the $28,000 base MSRP tells the institutional market almost nothing about the program's ultimate profitability.
Base price is an advertising metric. To model the actual platform economics, institutional analysts require the average selling price, or ASP.
We need to see the trim mix consumers actually order. We need the final battery mix between standard and extended range.
We need the actual manufacturing yield from the Louisville plant, the warranty performance over the first critical 24 months of customer driving, and the finalized negotiated supplier costs.
Only when you have those variables does the actual production volume mean anything to the balance sheet.
Oh.
Ford has explicitly stated that both affordability and profitability are core objectives of the Universal EV program.
But notice that they strategically did not publish a guaranteed per-vehicle margin for the Fathom at the launch announcement.
Because the truck's true purpose in their portfolio is to prove that this clean sheet system deserves to scale. If Ford utilizes the exact same core architecture, the same electrical systems, the same software stack, and the same manufacturing methodology across 3 or 4 future high-volume vehicles, the initial engineering bill is distributed.
That is the true definition of platform economics. The Fathom does not have to carry every single dollar of that development cost forever.
But again, that assumes consumer adoption aligns perfectly with the factory output. We have to shift our perspective from Ford's corporate balance sheet to the listener's household cash flow. Consumers do not experience car ownership as an MSRP or a corporate capital expenditure.
No, they experience it as monthly cash leaving their personal bank account.
The total cost of ownership comprises financing rates, insurance premiums, household energy costs, maintenance, and, most critically, depreciation.
Residual value creates a massive structural tension for manufacturer strategy. It directly connects the vehicle transaction today with the consumer's monthly payment tomorrow.
If lenders expect the Fathom to be worth a substantial percentage of its original purchase price after 3 or 4 years, they finance a much smaller amount of depreciation. That severely lowers the monthly lease or loan payment.
If, however, the secondary market is uncertain about how that specific LFP battery ages or how expensive collision repair might be for those massive aluminum unicastings, lenders price that massive risk directly into the financing.
A $28,000 vehicle can become mathematically punishing to own on a monthly basis if its depreciation is severe. Suddenly, a cheap vehicle costs $700 a month to finance.
And that restricts the manufacturer's ability to adjust retail pricing. Lowering new car MSRPs to artificially stimulate demand during a slow quarter severely damages the resale value of the vehicles already sitting in customer driveways.
The new buyer entering the market today benefits from the temporary discount, but the loyal owner trying to trade in yesterday's vehicle absorbs a massive financial loss.
That volatility destroys residual value confidence across the entire brand.
Adding immense financial pressure to this equation is the regulatory cliff the market just crossed. The U.S. Federal Consumer Clean Vehicle Tax Credit officially ended for vehicles acquired after September 30, 2025.
When Ford announced the Fathom's sub-$30,000 pricing in August 2026, the old federal purchase subsidy was entirely gone. It was no longer available to mask the underlying cost of the vehicle.
That policy reset forces the issue into the light. A federal subsidy essentially closes the gap between what a vehicle actually costs to manufacture and what a median customer is willing to pay.
When you remove that subsidy from the market, the MAP demands an immediate resolution. Either the customer pays a higher transaction price, the manufacturer accepts a severely compressed profit margin, or the underlying structural cost of manufacturing has to materially improve.
Tariffs on imported components or foreign vehicles can protect the domestic market, and they can certainly buy time for legacy automakers to retool, but protectionism cannot substitute for actual manufacturing efficiency.
No, it cannot.
This brings us to the systemic fallout of this platform and the two highly distinct outcomes for Ford. In the strong outcome, the Louisville assembly system hits its engineering design expectations and achieves incredibly healthy utilization.
The domestic LFP strategy successfully controls battery costs.
Residual values stabilize in the secondary market, and Ford successfully scales the underlying architecture into additional high-volume products, structurally lowering the cost per unit across the board.
The weak outcome looks very different, and it is crucial to understand that the truck can be wildly popular while still utterly failing this financial test.
Popularity and profitability are completely separate metrics.
Exactly. If ramp-up rework slows the assembly line, or if consumer demand over-indexes on expensive configurations while the advertised base model remains structurally unprofitable to build, the platform fails.
If factory utilization remains too low to efficiently absorb that $5 billion in fixed costs, the program damages the broader corporate balance sheet.
That establishes the real scoreboard for institutional observers. Do not focus on launch week reservation numbers. Watch the factory utilization rates at Louisville. Watch the operational margin.
Track the gap between the $28,000 base price and the actual transaction prices moving through dealerships.
Monitor the real-world battery durability and its impact on the secondary market. And most importantly, watch to see if subsequent vehicles actually emerge utilizing this exact platform.
Because the strategic winners and losers in this specific transition are clearly defined. The winners will be a highly utilized Louisville plant, the Michigan battery operation securing steady automotive demand, and the suppliers who survive the simplified architecture to gain massive volume across multiple models.
The losers are the suppliers losing content due to the 20% reduction in parts, the inefficient assembly workstations that were engineered entirely out of existence, and the previously existing Ford products that suffer brutal cannibalization if Fathom buyers are simply trading in older Fords rather than migrating from competing automotive brands.
The Fathom proves that the old era of hiding manufacturing inefficiencies behind premium trims is completely over. At $28,000, affordability cannot be a manufacturer-funded discount. It must be a fundamentally engineered property of the vehicle from the very first blueprint.
But before we close this out, consider this macro implication. If Ford successfully drives the structural cost of a highly capable new electric truck below $30,000, what happens to the millions of used gas-powered trucks sitting on dealer lots today, priced at $40,000?
Are we about to see the greatest collapse in used vehicle household equity in modern history? Tell us which variable will ultimately decide mass market EV economics. Battery cost, factory utilization, or ownership cost? Subscribe to the Unlayered Global for more analysis of the financial systems underneath the auto industry.